In this video, I'm going to talk about upcasting. All right. So again, as a quick review, we're using our shape object here, which has this one attribute color. It's got a getter, it's got a setter, a constructor, a toString, and it has this public double compute area method. We also have a circle class, which extends shape. So circle is a subclass of shape. It's got a radius attribute, it's got a getter, a setter, a toString method, and it has an overridden public double compute area. All right. So if I go over here and I say, all right, the first thing that I'm going to do is I'm going to just go ahead and create a new circle object. All right. Because I haven't done anything weird here, I can call all of the different methods available to me in both circle and shape. Okay. So I could do C1. If we go look here in circle, I could go ahead and do c1.setRadius 10 if I wanted to. All right, I could also call the public methods that are defined here in shape, so I could set the color to green. All right, and I could call c1.compute area if I wanted to, and that would of course call the compute area that's defined here in circle, because that's the overridden method. And so you'll see that this compiles just fine. Now I haven't actually printed anything, so it won't actually do anything if I run it. It'll just see it, just nothing happens. But I could print out any of these things if I wanted to. Okay, so now what we're going to do is we're going to upcast this circle to a shape object. All right, and so there's a couple of ways that I can do that. The first is I can just simply do shape S1 equals C1. Okay, and so basically all I've done is I've said, all right, I have this circle object here called C1, and now instead of referring to it as a circle object, I'm just going to refer to it as a shape. Okay, so if we go back to the diagram from the previous video, okay, you will see that now that I have this shape reference, that means I can only execute these functions inside of here. Okay, so if I was to try and do, for example, s1.getRadius, okay, this is going to give me a compiler error because getRadius is not, again, going back to my diagram, okay, getRadius is not defined here in shape, and now I have a shape reference. Okay, so this should, when I compile it, it complains at me and it says, nah, there's no getRadius because you're now referring to this blob in memory as a shape. Okay, but this is an example of a upcast. All right, now the other thing that you can do is I could say shape S2 equals, and I can put the object type in parentheses here and explicitly cast it. This used to be how you had to do it back in like the Java 1.4 days, where you had to explicitly put this in, but it's not necessary. So this is just sort of an optional syntax you can do, and you'll see that this compiles just fine. Okay, so that's upcasting. Now, the question is, why would you ever want to do that? Well, you might not necessarily want to do it in this simple example, but in other things that we've gone over where, for example, let's say that we had an array of shape objects, okay? That's a case where you might want to refer to things as just shapes, okay? So anyway, that's upcasting in a nutshell. Just keep in mind that if I do this, I can now only execute, again, going back to my diagram, I can only execute the functions that are here defined inside a shape. Now, the exceptions are this compute area and toString, okay? So let's take a look at that really quick. Even though I now have this shape reference, what would happen if I did system.out.println S2? And I'll explicitly just call the toString method so it's obvious what's going on here, okay? So what's going to happen when I do this is s2.toString, if I go back to my well, actually, before I go back to my diagram, S2, remember, is a shape reference, okay? And I'm calling the toString method. So now if I go back to my diagram, this shape reference toString, Java knows that this is a circle. So even though I'm referring to it as just the shape portion of that circle, it knows that it's a circle. So when I execute toString, it's not going to execute the toString defined in shape. It's going to execute the toString defined in circle. Okay? And so let's actually watch this happen. When we run it, see how it prints out? It doesn't print out anything about the shape. Remember, the shape's toString method would have just said, this is a generic shape, its color is. But because we actually have a circle, again, we're referring to it as a shape here, but it's actually a circle. That's what we really have in memory. It's going to go ahead and execute circle's toString method and say it's color green and its radius is 10. Okay? So, and likewise, the same exact thing would happen if we went ahead and did system.out.println s2.compute area. Okay? Again, S2 is a shape reference, but I'm not going to call the compute area that's defined in shape, which would just return 0. That compute area method has been overridden, and so it's actually going to execute this one. If I go back to my diagram, I'm referring to this blob as a shape. I'm trying to execute compute area, but because this isn't really a shape, it's really a circle, it's going to go and it's going to execute this compute area. Okay? So I find it helpful sometimes to draw this sort of memory diagram, and all of the functions that are overridden, you just draw these lines to. And then when I'm referring to it as a shape, I know exactly what's going to happen. When I'm referring to it as a circle, I know exactly what's going to happen. That's just a strategy that works for me. Okay, so again, if I go back over here to my implementation, after I do my s2.compute area, you will see that it prints out 314. So the radius is 10, so 10 times 10 is 100, times pi is 314. So this right here, again, this is the example of upcasting, where I'm taking my subclass, which is circle, and I'm casting it to the superclass. And basically, I'm just referring to the shape portion of that circle.